All right. Welcome to the first Wednesday talk. I'm delighted to be giving it. It is exactly 12:45 a.m. on Wednesday. I'm in Spain. I was not planning on being here when I submitted my abstract. Okay, so I'll be giving you an update on something that I talked about last year, which is widely distributed exogenic materials of varying compositions on the surface of Bennu. Here's the outline. I'm going to give you a little bit of a background about the first paper on this by Della Justina et al. 21, then a paper on the surface of Ryugu by Tatsumi et al., and then this paper that I'm reporting on. It's the Tatsumi and Popesco et al. 2021, got published late last year. And so we have new candidate exogenous material on Bennu. 71 new boulders. Oops, this thing is changing by itself. 71 new boulders, in addition to the 6 that had already been identified by Della Justina et al. And we identified them by both high albedo and an absorption in the X band, which is at 0.85 microns, indicative of anhydrous silicates. And we conclude that there are 2 types of compositions that are mixed in with the average Bennu composition. One would be HEDs, in other words, Vesta materials, and the other one would be ordinary chondrites. And then I'll give you the conclusions. So now it's not letting me forward my slide. Can you see? Okay. Initially got reported by Della Justina et al. And Tatsumi et al. For Bennu and Ryugu, respectively. They used albedo, color, and spectra in the case of Bennu, 6 boulders that were distinct from Bennu's surface and were likely basaltic materials, specifically from asteroid Vesta. The bright boulders identified on Ryugu show absorptions near 1 micron, but not near 2, suggesting olivine-rich anhydrosilicates more akin to ordinary chondrites. And in this work is what I will be discussing today. These are the images that were published in the Della Justina et al. Paper of their first 6 boulders. Now we have the new candidate exogenous material that we used images with both MapCam and Polycam on OSIRIS-REx, and we identified these 77 boulders that are likely exogenous material, widely distributed throughout Bennu. Here's the distribution in latitude and longitude, and here's the distribution overlaid on the map of Bennu. They were more likely found in areas with larger particle size distribution, in other words, rockier terrains. Here are the 3 morphologies that we found. We found homogeneous boulders, we found breccia-like boulders, and we found inclusions-like boulders. We found 2 spectral mixing trends with respect to average Bennu. One of the trends can be explained by mixing Bennu with HEDs or Vesta material, as suggested by Della Justina et al. And the other trend that we find is by mixing this olivine-rich anhydrous composition consistent with ordinary chondrites. So it is likely that Bennu has both impact or impactor material from Vesta and from ordinary chondrite type or S-type asteroids. The near-infrared spectra with OVIRs also supports our conclusion from the camera work of multiple compositions among the exogenic material on Bennu. And I will show you some of the spectra that were published by Amy Simon et al. In 2021. And so we have different spectra that indicate different slopes, different depth of the 1 and 2 micron feature among some of the objects that we identified as likely exogenic based on the albedo and the colors. An initial comparison between Ryugu and Bennu indicates that Bennu has more abundant exogenous boulders than Bennu does. And here are the conclusions, and it's that we found exogenous material beyond those found by Della Justina et al. On Bennu. We find clear diversity among this material with two spectral mixing trends, one HEDs and Vesta type material, and the other one with ordinary chondrite type material. I am open for questions, but not too many because I'm ready to go to bed.
Thank you, Humberto. Well, while we wait for more questions, I have one for you. Have you compared their locations in latitude and longitude with the really beautiful geologic map, the global geologic map published by Erica Jawin last year?
We have not used her map, but I'd be delighted to do that. So, Erica, let's talk.
Yeah, I assume Erica is still online, but I think in the end, the global the primary difference in geologic units was roughness or almost particle size. So the big bouldery regions were all in similar units, and you said that's where you preferentially find your bright boulders. So there might be a good correlation to check there.
Yeah.
Yeah, Kevin, I couldn't find my unmute button. Oh, start my video. I couldn't find my unmute, sorry. But Humberto, let's definitely talk because that was exactly my thought. It looks like the boulders are concentrated in the rugged unit that contain larger boulder sizes, like you mentioned.
For the paper, we used this map, which was what was available. But now that yours is available, we should do a more detailed comparison. So absolutely, let's talk.
We have a question in the room.
Hey, Humberto, you don't know me, but I'm Akbar Wizen.
Oh, I don't?
Just kidding.
I don't know you anymore? Anyway, go ahead, Akbar.
No, I'm wondering about the exogenic material on Bennu and Ryugu, and was reading recently about the appearance of these materials and that it's possibly indicative of a CI or CM meteorite type and allowing us to more closely match that. Is that right?
I'm not sure I understood the question. Could you repeat it? What's the CI and CM? Would that be
I think there were some efforts to try and link the materials found in the mascot cam and other close-up imagery to the meteorite classes. So
correct.
The link between the meteorites and the C complex B-type. So I'm just wondering if you have any thoughts on that in terms of this exogenic material you're looking at.
Well, in the case of Ryugu, the Tatsumi et al. Paper, they conclude that some of their material could be carbonaceous. It's just higher albedo carbonaceous. So you could have different types of carbonaceous material on the surface of Ryugu. In the case of Bennu, it does seem to be carbonaceous and much more igneous, or much more of an ordinary chondrite type material. I'm not sure if I'm answering your question. I'm not even sure I understood it. Akbar, we can talk offline some more if you'd like.
Yeah, absolutely. It's good to see you, Humberto.